Good morning. Welcome to Unique World Education YouTube channel. So this is Shihabuddin, mathematics teacher, as you know. Currently we are discussing the question paper, 10th grade mathematics question paper from CBSE official website. So next we want to discuss the section C, that means question number 6 onwards. Okay. So from the question number 6, the question is that there's a triangle ABC and D, E and F are midpoints of BC, CA and AB respectively. It is given F, E, D are midpoints. In 10th grade, in 9th grade, we are studied midpoint theorem. There's a midpoint theorem. The same midpoint theorem we are using here. The midpoint theorem is saying that for a triangle ABC, two midpoints are there. If you are joining these two midpoints, the line is parallel to the third side. More than that, the FE is equal to, the length of FE is equal to half BC, so called midpoint theorem. So the same midpoint theorem we can use here, because here we have the triangle ABC, and in triangle ABC, F and E are midpoints. So by midpoint theorem we can say that FE parallel to BC. FE parallel to BC, we can use midpoint theorem. F is parallel to BC. If F is parallel to BC, we can say that FE is also parallel to BD, because D is on the line BC, or D is the midpoint of BC. This is by midpoint theorem. Okay, so in this question, we are coming to the question here. In this question, prove that FBD, what is FBD? This one is FBD. This FBD is similar to FED. We want to show that these two triangles are similar, or DEF. We want to show that these two triangles are similar. So we can use midpoint theorem. That means by using midpoint theorem, FE is parallel to BD. So first of all, we just consider the triangles. Consider triangle FBD and the triangle DEF. FE parallel to BD by midpoint theorem. So F is parallel to BD, then we can consider these two angles. Alternate interior angles are equal. So simply we can write angle BDF equal to angle EFD. The reason, alternate interior angle. Alternate interior angles are equal. Then the similar midpoint theorem we can use for this ED and FB. Both are parallel because E and D are midpoints. So again we can consider E and D are midpoints. So therefore ED is parallel to the third side AB. If ED is parallel to AB, then ED is parallel to BF. Because F is a point on the line AB. So therefore these two angles, which are these two angles, are equal. They again alternate interior angles. So we can write angle BFD equal to angle FDE. So two angles are equal. So by AA criteria, for similarity we have so many criterions. So by AA similarity, triangle FBD similar to, it's not FBD, FBD similar to triangle DEF. Then what's next question? Here DEF and ABC. We want to show that DEF and ABC are similar. ABC, where is ABC? This one is ABC. ABC, the entire triangle. DEF, the small one is DEF. So we want to show that similarity. So again we can use AA criteria because we know that these sides are parallel. This side and this side are parallel. So that means these sides are parallel and these sides are parallel. So we'll get, look at here, this is a parallelogram. This one is a parallelogram. So it's a parallelogram. So for a parallelogram, opposite angles are equal. So in same way we can show that. So this is from the last one, that means from here. So it's the same way we can show that. The same way we can show that this is a parallelogram. This is a parallelogram. So that means opposite angles are equal. Okay, again consider next parallelogram. So it's simple, we know that. Consider this parallelogram. We can say that opposite angles are equal. So by AA similarity, these two triangles are equal. Is it clear? So we can consider the quadrilateral. Consider the quadrilateral AFDE. We know that ED is parallel to AF by midpoint theorem, and AE is parallel to FD by midpoint theorem, and more than that, both are equal because ED is equal to half AB, or we can write ED equal to half AB. Half AB means AF. So for a quadrilateral, opposite sides are parallel and equal, then it is a parallelogram. So from here we can say that therefore AFDE is a parallelogram. So for a parallelogram, opposite angles are equal. So therefore, in this parallelogram, angle A is equal to angle FDE. The reason, opposite angles are equal. Okay, by using this parallelogram. So similarly we can prove that. Consider the second one. Consider FDCE. This one, FDCE. In FDCE, FD is parallel to EC by midpoint theorem, and FE is parallel to DC, or we can say that FD is equal to half AC. This half AC is equal to EC. So therefore here is also we can say that the quadrilateral FDCE is a parallelogram. Okay, so opposites are equal. For a parallelogram, opposites are equal. So therefore angle C equal to angle EFD. That's all. Two angles are equal, so by AA criteria, by AA similarity, triangle ABC, or in this question it is given that DEF, similar to triangle ABC. Okay, then 26 or question, what is that? In triangle ABC, PQ are points on AB and AC respectively such that PQ is parallel to BC. PQ is parallel to BC. PQ is parallel to BC. PQ is parallel to BC is given. PQ is parallel to BC is given. Prove that the median, AD is the median from A on BC bisects PQ. We want to show that this bisects PQ. Which one? This median AD will bisect PQ. So we want to show that PR equal to QR. Okay, we want to show that PR equal to QR. So look at here. First of all, we are considering these two triangles. That means consider the triangle APR and triangle ABD. Because we know that this PQ is parallel to BC, so corresponding angles are equal. That means angle APR equal to angle APR is equal to angle ABD. Angle APR is equal to angle ABD, and there is a common angle A. A is both. So this is corresponding angles are equal. Corresponding angles are equal here. And so corresponding angles are equal. Just write the reason. Okay, corresponding angles are equal, and angle PAR equal to angle BAD, common angle. So that's enough for a similarity. So by AA similarity, we can say that triangle APR similar to, only one line is there, similar to triangle ABD. So if two triangles are similar, we can say that the sides are in same ratio. That means AP by AB equal to PR by BD equal to AR by AD. Equation number 1. Similarly, we can show that triangle, the left side, these two, triangle AQR similar to triangle ACD, and we can use the proportional. That means AQ by AC is equal to QR by DC equal to AR by RD. AR by RD. Now look at here, this is equation number 2. Now look at the equation number 1 and 2. AR by RD. Oh, this is by mistake. This is AR by RD. Sorry, here this is AR by AD. Okay, AR by AD. Because this is the triangle ADC. So AR by AD. In equation number 1 and 2, AR by AD is common. So we can say that this PR by BD, look at here this one, PR by BD is equal to QR by DC, because the right sides are equal from 1 and 2. From 1 and 2 we can conclude like that. So from 1 and 2 we have PR by BD equal to QR by DC. So what is BD and DC? AD is the median. AD is the median. It is given AD is the median. Therefore, BD equal to DC. So for a proportional, the denominators are equal, then the numerators are also equal. So PR is equal to QR. PR and QR are equal. That means AD bisects PQ. Okay. Then look at this 27th one. 27. The two numbers is sum of two numbers is 18 and the sum of the reciprocals is 9 by 40. Find the numbers. That's the question. Find the numbers. So here, sum of two numbers. So first number, just consider or let the first number or one number, that's enough, not first and second, just one number or first number is x. Sum of numbers is 18. So sum of numbers is 80. So therefore second number should be 80 minus x. Second number should be 80 minus x. Then the second statement, sum of the reciprocals is 9 by 40. So numbers are x and 80 minus x. Sum of the reciprocals is 9 by 40. Reciprocals means 1 by x plus 1 by 80 minus x is equal to 9 by 40. So by cross multiplying, we'll get 80 minus x plus x whole divided by x into 80 minus x is equal to 9 by 40. So we can cancel x and x. So it will be, oh sorry, it is not 80, it is 18. Read the question very carefully. A small mistake. But the question is different. So look at here, this is 18, 18. The examination, read the question very carefully. It is 18, 18, okay. 18 minus x plus x. So 18 is there. I am taking this 40 into right side, sorry, left side, and 9 into left side again, so it will be denominator. I am taking this x into 18 minus x into right side, so it will be x into 18 minus x. So obviously we can cancel 18 and 9, it will be 2. So this one is 2 into 4, 80 equal to 18x minus x square. So it's a quadratic equation. So I'm taking this x square and 18 minus x into left side. So it will be x square minus 18x plus 80 equal to 0. How we can factorize this one? The constant is 80. What are the factors of 80? We have, 10 and 8. Because if we are multiplying minus 10 minus 8, it will be plus 80, and if you are adding these two, we'll get minus 18. So we can factorize this polynomial as x minus 10 into x minus 8 equal to 0. Or we can use, if you are confused with this factorization, we can use x equal to minus b plus or minus root of b square minus 4ac all divided by 2a. Or you can use this method to this formula for finding solution of a quadratic equation. Or better, just factorize. If it is not possible, just use the formula for finding the values. So here, two solutions, x minus 10 equal to 0 or x minus 8 equal to 0. So we have x equal to 10 or x equal to 8. So these are the numbers, 10 or 8, two numbers. Then 28th question, look at the 28th one. If alpha and beta are zeros of the polynomial 6x square minus 5x plus 1. 6x square minus 5x plus 1 is the polynomial. We have the relation between alpha and beta. Alpha plus beta is equal to minus b by a. So here alpha plus beta, minus b means again minus 5, a means 6. So alpha plus beta is equal to 5 by 6. And alpha into beta is c by a. So here alpha into beta is equal to 1 by 6. These are the relation between zeros and the coefficients of the polynomial. Now what's the question here? Then from, just a minute. Yeah, then from here Form a quadratic polynomial whose zeros are alpha square and beta square. So we know that if there is a 0 alpha square, or if there is a 0 alpha square and beta square, so we can find the polynomial alpha square and beta square are the zeros. So x square minus the zeros alpha square and beta square into x plus product of zeros, that means alpha square into beta square. So this is the polynomial. Now we want to find what is alpha square plus beta square by using these two equations. By using these two, we need to find alpha square plus beta square. So it's very easy to find because we know that a plus b whole square. So alpha square plus beta square. How we can find alpha square plus beta square? We can use a plus b whole square. A square plus b square plus 2ab. So a plus b whole square. We'll get a square plus b square plus 2ab. So you want to subtract that 2ab. So alpha plus beta is equal to 5 by 6. So 5 by 6 whole square. 2 into alpha into beta is 1 by 6. So this is 25 by 36 minus 1 by 3. So what is that? 3 into 25, 75 minus 36. 3 into 36. 3 into 36. What is 3 into 36? 3 times 18, 1, 9, 108. So alpha square plus beta square is equal to, so this is equal to, or I think better we can use, yeah. So better we can use LCM, then we can easily solve this one. If you are using the LCM, we can easily solve because cross multiplication, if you are using, we want to simplify again. If you are using the LCM 3, that means here 4 times we are multiplying with 12. We are multiplying with 12. We'll get 36. That's better. Use the LCM. So 36 is common, or the denominators are equal. So we can subtract the numerator. 25 minus 13, that is, 25 minus 12, that is 13. So 25 minus 12, that is 13. So 13 by 36. Now, next one, alpha into beta. So we need to find alpha square into beta square. Alpha square into beta square. Alpha square into beta square. That means alpha into beta whole square. What is alpha into beta? 1 by 6. So 1 by 6 whole square. That is equal to 1 by 36. Now just write the just substitute the values and just write the polynomial p of x, or we can write here. Therefore, the p of x equal to x square minus alpha square plus beta square is 13 by 36x plus 1 by 36. So if you are multiplying with 36, we'll get coefficients as integers. So 36x square minus 13x plus 1. Okay. Then 29 cos theta plus sin theta is equal to 1. Cos theta plus sin theta is equal to 1. We need to find cos theta minus sin theta is equal to plus or minus 1. That's the question. We want to prove that. Not find, we want to prove that. So cos theta plus sin theta is given. Okay. So cos theta plus sin theta is given. That is 1. we want to express cos theta minus sin theta. From cos theta plus sin theta, just square both sides. So we'll get cos square theta, that means a square plus b square plus 2ab equal to 1. Now 2 sin theta cos theta. So cos square theta plus sin square theta plus 2 sin theta cos theta. I'm taking this one as cos square theta plus sin square theta. And I'm taking this 2 sin theta cos theta into right side. So cos square theta plus sin square theta is 1. And I'm taking this 2 cos theta sin theta into right side. So it will be cos square theta plus sin square theta minus 2 sin theta cos theta. So a square plus b square minus 2ab. We know that this is cos theta minus sin theta whole square. So this one is, this cos square cos theta minus sin theta whole square is equal to 1. Then how we can solve a quadratic equation? For example, x square equal to 1, then x equal to plus or minus 1. So like that, here cos theta minus sin theta whole square is equal to 1. So cos theta minus sin theta equal to plus or minus 1. It's an easy question. So it's very simple, but we are using some logic. Okay, because we want to introduce cos theta minus sin theta. Now the 30th one. A minute hand of a wall clock is 18 centimeter long. Find the area of the face of the clock described by the minute hand in 35 minutes. So we know that for a clock, if one rotation is finished, we'll get 360 degree. That means 60 minutes means 360 degree. So 1 minute is 360 by 60 degree. So that means we can cancel 0, 0, 6 and 36, will get 6 degree. 1 minute means 6 degree. So here 35 minutes. So 35 into 6. So 35 into 6 means 0, 3, 2, 1. So 210 degree. Now angle is given. We found the angle and radius is given. Minute hand. The minute hand of clock is 80 centimeter long. So we can find the area. So area of the face is equal to area of the sector. So we have the equation for area of the sector, that means theta by 360 pi r square. So here theta is 210, 360, pi means 22 by 7. Oh, here if I am writing here, you can't see anything. I'm very sorry. If I'm writing here, you can't see. So okay, area of the sector. Area of the sector is equal to theta by 360 pi r square. So theta, we found the theta 210, 360. Pi means 22 by 7. R square is equal to r. The radius is 18 into 18. Okay, so we can cancel 0 and 0. We can cancel 2 and 21, it will be 3. Then we can cancel this 18 and 36 two times. Again we can cancel 18 and 2, it will be 9. So we have 3 into 22 into 9. So that means 66 into 9. So what is 66 into 9? That is 4, 5, 4. Okay, 5, 9 centimeters square. Okay, 594 centimeters square. Or square centimeter. Then a B question is there. What's the B question? Look at your AB is a chord of a circle such that it is given that angle AOB is 60. Angle AOB is 60. OA is 14. OA is 14 means radius is 14. From the figure, OA is 14. So this is 14 and this is 60. One angle of a triangle is 60. More than that, these two sides are equal. That means isosceles triangle. So these two angles are equal. So surely it will be 60 and 60. So it is an equilateral triangle. What's the question here? Find the area of the minor segment. Find the area of this portion. That's the question. We want to find the area of this portion. Okay. So first of all, we can describe the triangle. Triangle AOB. OA equal to OB. Therefore, angle A equal to angle B. The reason, angle opposite to OA and OB. And given that angle AOB equal to 60 degree, so by angle sum property, we have angle A plus angle B plus angle O is 180. So therefore we have angle OAB, that means angle A. Angle OBA, that means angle B is equal to 60 degree. So therefore triangle AOB is an equilateral triangle. For an equilateral triangle, how we can find the area? Area is equal to root 3 by 4 a square. Okay, root 3 by 4 a square is the area of this triangle. Now the question is that we need to find the area of the segment. So area of the segment is equal to area of the sector minus area of the triangle. Area of the sector, theta by 360 pi r square, minus area of the triangle is root 3 by 4 a square. So theta is given 60 by 360 pi means 22 by 7. R, that means 14 into 14. Root 3, they are saying that we want to use 1.73 by 4. A square, OA is given 14. So again 14 into 14. So we can cancel 0, 0, 6, 6. We can cancel 7, 14. So here it will be 2 times. It will be 6. We can cancel this 2 and 6. It will be 3. So it will be 14 by, sorry, not 14. 1 by 3, 22 into 14. Here we can cancel this one. It will be 7 and 2. Again we can cancel. It will be 7. So it is 49 into 1.73. Okay. So 22 into 14. What is? So 102.67. The final answer. Actually this is 22 into 40 means then 49.173, that is here. So 49 into 103 is equal to 49 to 103 is equal to, we can multiply 49 173. So 7 2, if you are multiplying, we'll get, I think we can find the final answer, that's better. We'll get 102.67. I won't waste the time for multiplying. 102.67. So now, sorry, not 102.67, 84.77. Yeah, 84.77. It is not 102, 84.77. So this one is 102.67 minus 84.77. So if you are subtracting these two, you will get 17.9. 17.9 centimeters square. Yeah, that's right, 10 centimeters square. Okay. Then the last one, 31st one. Prove that root 3 is an irrational number. So it's purely, we don't need to solve anything, because the same method for any question related to root 3 is, if you want to show that a number is an irrational, we are following the same method. In every question we are following the same method. So first of all, we are considering the number or the contradiction, or assuming the number is not an irrational number. So we are considering root 3 is a rational number. So first of all, we are considering root 3 is a rational number. That's the first step. That means we are writing root 3 is equal to p by q. The same method we are using in any question. So assume that root 3 is rational. So root 3 is equal to, we can express a by b form, where b not equal to 0 and a and b are coprimes. Coprime means there is no common factor. Only one is the common factor there for a and b. Now we are taking this b root 3 equal to a, then squaring both sides. We'll get 3b square equal to a square. Equation number 1. That means from here we can say that 3 or a square divisible by 3, or 3 is a factor of a square. or we can say that a square is divisible by 3. So from here we can say that a is divisible by 3 by a theorem. There's a theorem. If p is divisible by a square, so a square is divisible by 3 by p, then a is divisible by p. So we can write a is equal to some 3p. We can express. Now from equation number 1, 3b square equal to 3p whole square. That means 9p square. So from here we can write b square is equal to 9p square by 3. That means again 3p square. So from here we can say that b square is divisible by 3. So therefore b is divisible by 3. So b is divisible by 3, a is divisible by 3. So therefore there is a common factor for a and b. So therefore 3 is a common factor for a and b. But look at here, a and b are co-primes, so it is a contradiction. It is a contradiction. It is a contradiction for co-primes. It's a contradiction for co-primes. So the problem is that the assumption. We are assuming root 3 is rational, so therefore root 3 is an irrational number. So the same proof we are using for every question, for root 3, root 5, root 11, root 7. Okay, so thank you. This is the section, next section. Now the next part I am planning to discuss that next section D. Okay, thank you, bye.